We're on a roll here. Weathering's up next. I'm going to start weathering with this. A brick. Okay? You've seen a brick. I've seen a brick. This is a regular brick. I'm going to show you another brick. And this is one that I found while at the ocean, Long Island, New York, in Bridgehampton in 2014. And it's this. Okay, check out this brick. See how different this is. Okay? And so this was in the waves. I was watching it. It was like rolling up on the beach and back on the beach and up on the beach and back on the beach. And I picked it up and grabbed it. Now, how do you go from this normal brick? How does it get like this? What a lot of people would say is it was caused by the water. But it's not really, the water doesn't do it. And this is about weathering. So it's about abrasion, a specific type of weathering. And it's physical scratching, scraping, rubbing. That is the rocks and pebbles and the sand rubbing up against that brick. The hardness will actually scratch it and cause it to be rounded. This is a type of physical weathering. Okay? Two types of weathering, physical weathering and chemical weathering. Physical weathering involves change in size and shape of the rock, but the chemical composition remains the same. So there's no chemical change or chemical reaction. Abrasion is a type of physical weathering. Know it. So, for instance, here's some Regents questions. These are all 4 pieces of quartz is what it says, so the rocks are all the same. Which appears to have been transported farthest by a stream. So what you're looking for, so this is really ocean waves and really streams. We see mentioned in streams more so. And so the answer is going to be 4 here, okay, because it's more rounded. This longer transportation by a stream causes it to be more rounded. Know it. Here's another. This question here says you have a pebble. They put it in a rock tumbler, which will tumble the rock basically with coarse sand for 5 days. So after 5-day periods, what might it look like? And the answer here is going to be 4. It's going to be rounder and smaller. That's what abrasion does. So these questions, pretty straightforward if you get one of these. Here we have, it says cavern formation, and cavern, caves, same things. We use the words interchangeably. And this here, this pattern, hopefully you recognize it, is for the rock of limestone. Sedimentary rock of limestone is shown, the symbol is this sort of brick pattern. And you see the caves here, some are filled with water. And how these form is a little bit different. Basically, caves are usually from limestone or marble, sometimes dolostone. And that is because acid rain reacts with the calcite, or any acidic water. So groundwater itself is usually a little bit of an acid, so it will react with calcite and sometimes dolomite. So hopefully in class you saw the drop acid on calcite and watch it fizz. It's totally cool, and hopefully you saw that. And that is a chemical reaction between the acid and the calcite. So this is chemical weathering here, and so it slowly dissolves the minerals in the rock. So know it, calcite and dolomite react with acid. This is essential to weathering. Now, oftentimes there's a series of questions. Any rock that has a lot of calcite or dolomite in it can have this reaction. So this is a sedimentary rock chart. It has the composition calcite, dolomite, therefore the rocks limestone and dolostone. Those are rocks that have this reaction. Below that, the metamorphic rock chart, you can see, well, limestone and dolostone, when they get metamorphosed, will become the rock marble. But it does have it in composition, calcite or dolomite. So oftentimes you just need to know to look there, and then there could be a series of questions about calcite or the rock or this process. So here's just another example. This is a question where they talk about caves, and somehow they ask about calcite or the rock type or something like that. Here's another example of some diagrams from a question: early stage, later stage, caves getting bigger, more dissolving of the calcite. Okay, now we're going to switch gears a little bit. So given in here, it says this is an arid region. Okay, now, important, arid means dry. Know it. Arid means dry, so not a lot of precipitation. Okay, and therefore you get different weathering and different kind of landscapes. So the question was, what would happen if the climate in this area became more humid? Okay, water is a key agent of all sorts of weathering. So more water, more weathering and erosion, and therefore what you're going to get is it's going to be more rounded. Okay, so not so flat, more rounded. That's key. Know it. This is a diagram showing sort of like, looks like the Grand Canyon, and this is a very arid or dry climate, hence these sort of flat topped, and it's very kind of angular. If it had more precipitation here, it would get more rounded. Switching gears again, which layer is most resistant to weathering? All these rock layers, which is most resistant? What's key is most resistant. I've seen time and time again, this drives kids crazy. Most resistant. It resists weathering the most. Therefore, it's been weathered the least. Okay, think about that. It is not asking which has been weathered the most. That's not that question. So for instance, B, because it's so far down here, I would say it is least resistant to weathering, and it has been weathered the most. Think about that. Therefore, the answer here is layer A is the most resistant because it sticks out. This has probably been weathered back a lot, all of these rock layers, but this has been weathered the least, most resistant. That is key. Here we see a diagram of Niagara Falls. Here we see another diagram of a much smaller waterfall. It has the rock ledge labeled here, and what is key to waterfall formation? Well, the top layer has to be more resistant than the layers below. Okay, if that's what has to happen for there to be a waterfall. If that wasn't the case, this would have eroded just as much as these, and it would be more of a very gradual slope, and the water would just kind of, trickle down it, let's say, or bubble down it. That is a key element to any waterfall. Now this is about soil. So this has a diagram here. It shows basically bedrock, quartzite, limestone, some lichens growing, but no soil. Time goes by, and we're talking probably hundreds or thousands of years, and you have a layer of soil. So how does soil form? Soil forms by two activities: weathering of the rock from bedrock into smaller pieces such as sand, silt, or clay, and biologic activity. Okay, and by biologic activity, I mean plants growing, dying, decomposing, leaves decomposing, worm poop, etc. Okay, that's what I mean by biologic activity. So you see a question like this. It shows a typical cross-section diagram of the ground. Which layer has the most organic and weathered material? Before we go further with that, the word organic means from a living thing. Forget what it is in the grocery store. It's kind of a different meaning. But for us, organic means from a living thing. So what layer has the most organic and weathered material? And it's going to be A. Right, towards the top. This is where all the life is really happening. All the plants are growing and the worms are up here. They're not 30, 40, 50 feet below. So that is important to know. Weathering. Ta-da!